Hello, today's topic is about duality in linear programming. Now, what is duality? So, duality is for every linear programming problem, there is a unique dual portion. The duality means if I am talking about a maximization, so there must be a minimization. So, two programs which are very closely related but exactly different results are there, they are formulated by the duality theory. Here in this video I will talk about the duality and its economic interpretation as well. So let's talk about the primal. So whatever the basic question will be provided to you, that will be called the primal, and from that, by some changes which I am going to talk, whatever you make, that will be called dual. For example, in the primal, if it is called maximization, in dual it will be minimization. So minimum will become maximum. Number of variables, whatever will be here, that will become the number of constraints. That means the equations. Number of constant will become the variable, so it's always on a vice versa manner in a both side reaction way. Now less than type constraints will become greater than. Equal to type constraint will not be changed, but they will become unrestricted. Okay, and objective function will become the objective function will become the RHS of the constraint, RHS of the constraints. And RHS of the constraint will become the objective function, and coefficients of jth variable in the ith constraint will there be a, and the matrix formation and the matrix of the coefficients we will just see in the matrix formation of the coefficient, we will see only one thing, and that is called the conversion. Into another one, and that is said to be the inverse, the transpose part. Okay. And there is one thing we need to remember, which is very important in duality, that is dual of a dual is a primal. Okay, it's a very basic structure. There are very other things we need to remember actually. Okay, dual of a dual is primal. Second one is if the primal or dual has a finite optimal solution, if primal or dual, any one of them has finite optimal solution, then the other one also possesses the same equation, same equal optimal solution. So number of optimal solutions in primal will be same as dual. Next, third here, if it is 1 and 2, third will be if any of the two problems has only one infeasible solution, then the value of the objective function of other is unbound. So if one infeasible solution, then the objective function is unbounded. Now let's proceed with a simple question that will ease some of the doubts which is still in your mind. Okay, so here we have maximize f of x equal to 2x1 plus 5x2 plus 6x3 subject to, so it's a three variable structure. The constraints are 5x1 plus 6x2 minus x3 less than equal to 3 minus 2x1 plus x2 plus 4x3 less than equal to 4 x1 minus 5x2 plus 3x3 less than equal to 1, and minus 3x1 minus 3x2 plus 7x3 less than equal to 6. That's it, where all the variables are greater than 0. So here, while solving this, the pattern is ax less than equal to b, okay, where capital X greater than equal to 0. Here a equal to the coefficients which is given in the given matrix. So a is directly can be written as in a 3 row 4 column, 4 into 3 actually. So 5 6 minus 1. Second one is minus 2 1 4, then 1 minus 5 3, and minus 3 minus 3 7. So this is given, and here b will be the RHS 3 4 1 6. Now all the things are less than, so we don't need to worry about anything, so we can proceed now. So the dual problem will be, let it be W, which is W1, W2, W3. So we are taking it as a row 1 because that is a column, so we are taking the transpose. So here, after changing into this matrix will be changed. We are taking the transpose actually. So 6 1 minus 5 minus 3 minus 1 4 3 7. That's it. And this W1 W2 will still be there, but here it will be 256. 256 is nothing but the coefficients of the main equation, so that 3 is coming over here. So this is our 2 5 and 6. That's it. Hence the final answer is minimize. So maximize will become minimize, as I said in the beginning. G of W equal to 3W1 plus 4W2 plus W3 plus 6W4, subject to a formation will be with respect to this one and row wise. So 5W1 minus 2W2 plus W3 minus 3W4 greater than equal to 2, and then 6W1 minus W2 minus 5W3 minus 3W4 greater than equal to this, that is 5, and then minus W1 plus 4W2 minus 3W3 plus 7W4 greater than equal to 6. All these less will become greater, and that's the answer of the first duality. Now what happens if in the duality some values are in less than or some are unconstrained in sign? So this one is type 2 in the duality pattern. Type 2, that is, the given question is max z equal to x1 minus 2x2 plus 3x3 and minus 2x1 plus x2 plus 3x3 equal to 2. So it's a special type equal to over here, and the second one will also have a equal to again. 3x2 plus 4x3 equal to 1, and the rest of the thing are same. So in this case, equal to means if I say x equal to 2, so in LPP manner we can write it in this way. So in order to incorporate the equal to part, we will proceed by equating it first less than and second time with greater than structure. So let's do it. So our first equation will become 2x1 plus x2 plus 3x3 less than equal to 2, and minus 2x1 plus x2 plus 3x3 is greater than equal to 2 as well. Now let there be equation A and equation number B. So now the equation B can be written as, equation B can be rewritten as we can take -2 common because we are dealing with, remember that LPP deals with one note is same sign. In LPP we have to deal with same sign, that is all less than. So in order to change B into less than, we can write it by taking minus common, 2x1 minus x2 minus 3x3 less than equal to -2. So similarly, from this equation also, we use a different color. We can write that two equations, that is 2x1 plus 3x2 plus 4x3 less than equal to 1, and minus 2x1 minus 3x2 minus 4x3 less than equal to -1. So now all we need to do is to form it. Now this won't be easier because there will be 4 equations. So minimize z star 2w1 dash minus 2w1 double dash w2 dash w2 double dash. So I am just putting it with respect to the equational format. Now the reason I am doing it is, and obviously this will be like 2w1 double dash plus 2w2 dash 2w2 double dash greater than equal to 1, and w1 dash minus w1 double dash 3w2 dash, and in that way we are proceeding here. And now comes the third one. The 4 part is done. Now here at the end we need to replace w1 dash minus w1 double dash by w1 and w2 dash by w2 double dash by w2. So hence the new dual will form as minimize z star 2w1 plus w2 subject to 3w1 w2 greater than equal to -2 and 3w1 plus 4w2 greater than equal to 3. So there here I have to mention that w1 and w2 are unrestricted in sign, as I have mentioned in the beginning, so they will become unrestricted in sign. Now in the next video we will talk about what happens if there is greater than with a minimization.